Hello everyone and welcome to Kiru's online lectures. I am Kira Jamtani and today's topic is alcohols, phenols and ethers, part 5. So in part 1 we studied introduction, classification, nomenclature and structure of functional groups. In part 2 we studied preparation of alcohols and phenols. In part 3 we studied physical and chemical properties of alcohols and phenols. And in part 5 we studied important alcohols, that is methanol and ethanol. Now in part 5 we are going to study about ethers. So starting with ethers, as we have already studied the introduction of ethers in part 1, now we'll start with the preparation of ethers. How to prepare ether? The first reaction is by dehydration of alcohols. So alcohols, that is CH3, CH2OH, it undergoes dehydration in the presence of protic acid like H2SO4 at 443 Kelvin. So when 443 Kelvin we take, here the removal of H2O takes place, that is dehydration, and thus we get alkene. But in the same reaction, H2SO4 we are taking, but the temperature is 413 Kelvin. That time we get ethers, which is C2H5O, C2H5. So formation of ether is basically nucleophilic bimolecular reaction, that is it follows SN2 mechanism. Moving on to next preparation, that is Williamson synthesis preparation. And now in this preparation basically alkyl halide is allowed to react with sodium alkoxide. We have alkyl halide, it reacts with sodium alkoxide. So here Na and X are removed, thus we get ROR, which is ether. Now here the important concept is, if we want to prepare tertiary ether, so for the preparation of tertiary butyl ether, alkoxide should be taken tertiary and halide should be taken primary. We will take like this: CH3Br plus alkoxide should be tertiary, which is CH3CCH3, CH3ONA. Over here when it reacts, so this Br and Na will be removed, it participates in elimination reaction. Thus we get CH3CCH3, CH3O, CH3. So if alkyl halide is primary, we get tertiary ethers. But in case of secondary or tertiary alkyl halide, if we are taking secondary or tertiary, like the example is over here of tertiary alkyl halide, if tertiary alkyl halide is taken, so this elimination reaction competes over substitution. Thus over here the substitution reaction takes place and thus we get alkene. So when tertiary alkyl halide is taken, the main product formed is alkene plus NaBr plus CH3OH. So H goes with this and NaBr forms as a byproduct. Now moving on to the physical properties of ethers. So the first physical property is the CO bond in ethers is polar, thus ethers have net dipole moment. Now weak polarity of ethers do not appreciably affect their boiling points, which are comparable to those of alkanes of comparable molecular masses, but their boiling point is much lower than that of alcohols, and the large difference in the boiling point of alcohols and ethers is basically due to the presence of hydrogen bond in alcohols. Like we have over here pentane. Now pentane has boiling point of 309 Similarly, we have ethoxyethane. It also has boiling point of approximate 307, which is approximate equal. But next we have, that is butane 1-ol. So the boiling point of butane 1-ol is 390. As we can see over here, the boiling point of alcohol is more as compared to the ethers. It is all due to the presence of hydrogen bond in alcohol. Now coming on to the solubility. Miscibility of ethers with water resembles that of alcohols. So like we have ethoxyethane and we have butane 1-ol. So these both are miscible to almost to the same extent. Thus we can say ethers and alcohols both are soluble in water. So now moving on to the chemical properties of ethers. So in ethers, as we know, the formula is ROR. So here this bond is broken, that is the cleavage of CO bond takes place in ether. Like we have ROR, it reacts with HX, so the bond breaks. Here comes here comes X and here comes H. Thus we get RX plus ROH. But if different alkyl groups are attached, that is CH3O, CH2, CH3. So in this case, halide group goes with the chain having less number of carbon. Thus X combines with CH3 and H combines with CH3, CH2O. So the product formed will be CH3X plus CH3, CH2OH. But if in this case, when HI is taken in excess and the reaction is carried out at high temperature, so ethanol reacts with another molecule of HI. This ethanol reacts with another molecule of HI and it forms CH3CH2I plus H2O. In the same case, if we are having tertiary ether, like we have CH3O, CH3O, CH3 and here CH3. So in this case, when HI reacts, so when this bond is broken, over here this bond is broken because tertiary carbocation is the most stable one. So over here this bond breaks and thus I comes over with the tertiary butyl group and here H comes. So the product formed is CH3OH plus CH3C, CH3I, CH3. So this is how the cleavage of CO bond takes place in ethers. Coming on to next chemical property, which is electrophilic substitution. Now as we have over here, this is anisole. So this anisole will take place and the halogenation reaction will take place over here. When we are performing halogenation reaction, we are taking bromine in ethanoic acid. Thus on halogenation it will form ortho, and because OCH3 group is ortho and para directing, so ortho bromoanisole and para bromoanisole will be formed over here. But para isomer which is obtained over here, it is 90%. So we can say the major product obtained is the para products. Thus it is OCH3 and Br. This is known as para bromoanisole plus we get ortho bromoanisole. So the major product formed over here is para bromoanisole. And this one is minor product, which is ortho bromoanisole. Now the next reaction is Friedel-Crafts reaction. So if we take over here CH3Cl in presence of anhydrous AlCl3 and CS2. So this is Friedel-Crafts alkylation, where CH3 group will be attached to ortho and para positions. So thus we will get over here 2-methoxy-toluene. This is the minor product which we get over here. Next, when CH3 group is attached to the para position, we get 4-methoxy-toluene. Similarly, if Friedel-Crafts acylation we are performing, that is performed with CH3COCl. So here COCH3 will be attached to ortho and para position. These para products are the major products formed over here. OCH3, here we get COCH3, this is 2-methoxyacetophenone, and in para position when it will be attached, so this is known as 4-methoxyacetophenone, which is a major product. Similarly, nitration takes place. Nitration takes place with HNO3 and H2SO4. So on nitration, NO2 group is attached to the ortho and para position. Thus we say it is 2-nitroanisole, which is minor product, and in para position nitro group will be attached. It is known as 4-nitroanisole, which is a major product. So in today's video we studied about the preparation, physical and chemical properties of ethers. Hope you guys are finding videos helpful. So do like, share and subscribe the channel. Thank you.